Welcome to Socket Lock's instructional video series. In this video, we will discuss socketing history, socket lock development and advantages, how socketing resin works, packaging and storage, and socket pouring procedures. For many years, zinc was used as a medium to terminate wire rope in a socket. Due to the hazardous nature of heating zinc to a molten state and pouring it into a socket, polyester resin was developed as an alternative and introduced into the marketplace in the 1970s. Today, it is the preferred medium used for this application because it does not corrode underwater, it is less hazardous to users, and it provides excellent long-term reliability. With many years of product experience under its belt, ITW Polymer Technologies, formerly Philadelphia Resins, teamed up with CFIT in 2009 to begin developing an advanced and improved version of the product, which is now CFIT's Socket Lock. With input and feedback from those most experienced in the field, the goal was set to produce the best resin product in the world. In 2010, after 2 years of development in the lab, static testing, dynamic testing, and shock load testing, the new version of Socket Lock was introduced to the market. Shortly after, Socket Lock received type approval from DNV and ABS. Advantages of Socket Lock are its high compressive strength and the fact that it is homogeneous and has consistent physical properties from top to bottom. These properties provide consistent wire rope grip throughout the resin cone. There is no powdered silica and chemical hardener to possibly be inhaled by the preparer, making it a safer product. The resin and hardener are now packaged in air-free foil packets, and these are kitted in durable plastic containers that will not rust, dent, or leak, and also serve as a mixing vessel. Each kit also comes with a mixing paddle and a unique, handy disposable funnel to eliminate spillage and mess. Socket Lock comes in standard kit sizes of 250, 500, 1000, and 2000 cc's. In addition, Socket Lock can be purchased in individual kit sizes for sockets ranging from 2 to 4 inches. Booster packs are also available for cold temperature socketing. As is the case with all polyester resin products, Socket Lock has a shelf life of 18 months when stored at 72 degrees Fahrenheit or 22 degrees Celsius. If stored at higher temperatures, it is important to note that the higher temperature will cause the shelf life to decrease. So it is always recommended to store Socket Lock in a cool, dry place. The expiration date can be found on the plastic pails and the boxes that contain the resin. Socket Lock's supply chain is designed to maximize the resin shelf life for users. The 18-month shelf life begins on the date the order is pulled from our New Orleans area distribution center. As load is applied to the rope, the resin cone is pulled downward in the bowl of the socket. As this is happening, the cone shape compresses the hardened resin cone against the individual wires and the socket walls. This compression then generates a tremendous frictional grip between the wires and the resin, resulting in a strength that exceeds the breaking strength of the rope. The following instructions have been prepared according to existing industry standards. For more information or alternative methods of preparing the socket, please reference the Wire Rope Technical Board Wire Rope Sling User's Manual or European Standard EN 13411-4. Determine if the socket has grooves. If grooves are present, fill the grooves with socketing putty to create a smooth socket bowl. If using wire for seizing, only use soft annealed iron wire. If using another seizing material, read the manufacturer's instructions carefully. Socket lock resin must be cured before the assembly can be used. Socket lock is not to be used with stainless steel rope in a saltwater environment. Never use oversized sockets for wire rope unless you consult the socket and wire rope manufacturer. Never use socket lock beyond the expiration date. Never heat the socket prior to pouring the resin in an effort to accelerate resin curing, as it may cause the resin to prematurely gel before reaching the bottom of the socket bowl. Exposure to some strong chemicals may affect the cured polymer in a way that could weaken the assembly. Always refer to the socket lock instructions supplied with the resin kit for a full safety and warning list. In addition to proper personal protective equipment for your work environment, these are the recommended tools to use for socketing: tape measure, marking crayon, seizing wire or tape, end cutting pliers, marlin spike, pipe, wire rope degreaser or solvent, socketing putty, tape, mixing paddle, fast funnel, wire rope lubricant. Measure the wire to be socketed, being sure to accommodate for the socket bowl length and dimensions of the socket. Wire rope socket assemblies can be fabricated with very tight length tolerances when assembled by an experienced rigger. Seize the rope on each end of the cut mark to prevent the rope from unwinding during and after cutting. Generally, your seizing length is at least one rope diameter, but some ropes, such as rotation-resistant ropes, may require more. Wire rope manufacturers usually have seizing guidelines for their particular rope types. Cutting is usually done with an abrasive wheel or shearing to reduce the likelihood of disturbing the wires under the seizing and to prevent changing of the metallic properties of the rope with excessive heat. If a torch or tapering machine is used, trim the ends of the rope to remove the heat affected zone. To determine where to apply seizing for brooming, measure the socket from the bottom of the socket to the top of the bowl. The end of the rope should be long enough so that the ends of the wires, after being broomed, will be at the top of the socket bowl. Mark the wire rope with a paint stick, lumber crayon, or other means that will be visible in later steps. Be sure the socket is free from dirt, grease, and other significant foreign matter before inserting the rope. Make sure you orient the socket correctly and simply slide the socket onto the rope. Seizing the wire rope before brooming is important because it holds the rope's preformed structure intact, ensuring the rope's strength and flexibility remains the same even after socketing. Seizing wire is the traditional material used for seizing. The seizing wire must be positioned one socket bowl length away from the end of the rope, and the seizing length must be at least 2 rope diameters long. Additional information is available from the Wire Rope User's Manual, Wire Rope Manufacturers Catalogs, or national standards. Seizing tape is a new method for seizing that provides the same securing strength as wire, reduces the time required for seizing, and doesn't unravel if broken during the socketing process. The seizing tape follows general seizing requirements such as it must be positioned one socket bowl length away from the end of the rope, and the seizing length must be at least 2 rope diameters long. Generally, the seizing tape should be at least 10 wraps thick and capped with 2 to 4 strands of wire at the top of the seizing. More detailed instructions can be found on CFIT's website or seizing tapes packaging. Using a marlin spike, begin to open the strands. Then take a sharp piece of pipe and bend each strand open to form a 60-degree included angle. Make sure the strands are opened evenly with equal spacing between the strands. During bending, the seizing material might need to be retightened occasionally. Should the rope have a plastic coated core, remove all plastic coating. And for fiber core ropes, cut out the fiber core. Be sure to thoroughly broom the wire rope down to the seizing and evenly disperse the wires in the broomed area. Proper resin penetration creates the friction needed to grip the rope and is dependent on how well the wires in the socket are separated and open all the way down to the bottom of the seizing. Read the manufacturer's precautions and instructions before handling solvent or degreaser. Swish the broomed out rope in the solution and make sure that the wires are clean from the very bottom of the broom up to the seizing. A brush may be required to reach all of the broomed area or remove large chunks of grease. After cleaning, place the broomed rope in a position that will prevent solvent from traveling towards the unbroomed section of the rope until all solvent has evaporated and the wires are dry. You can use compressed air to expedite the drying process. Solvent should never be permitted to remain on the rope or on the serving band, since it will run down the wires when the rope is turned upright. Please note, clean solvent is recommended to achieve the best results. Pull the socket up over the rope broom. Then place the socket and rope vertically in the final position that you intend to pour the resin. The socket should be positioned high enough that there is a minimum length of 30 rope diameters before the rope begins to bend. 20 rope diameters are sufficient if you secure the rope to the socket pouring stand or another fixture that eliminates bending. Make sure the broomed wires are uniformly spaced in the socket bowl, with the wire ends even with the top edge of the bowl. The top of the seizing should be even with the bottom of the socket. Be sure not to allow any broomed wire to extend below the base of the socket. Ensure the axis of the rope and the axis of the socket are aligned from all angles. A socket assembly that is properly aligned during the pouring of the socket will allow for even distribution of forces on the wire and resin cone, creating a holding force greater than the breaking load of the wire rope. If the rope is not properly aligned while pouring the resin into the socket, the rope will be set at an angle. Testing has shown that when this occurs, the rope is likely to break at the base of the socket below the catalog breaking strength of the rope. Sealing prevents excessive resin from escaping the base of the socket. Voids may be created near the bottom of the socket bowl, causing premature failure if too much resin escapes. To seal properly, wrap the bottom of the socket with socketing putty, being sure to press the putty into the valleys between the strands. To provide a greater seal, wrap tape over the socketing putty. Larger wire has larger gaps between the strands and will require much more putty than smaller rope. When the wire rope end has been properly prepared and the socket is positioned and ready to accept the resin, begin to unpack the kit containing the resin and hardener. Ensure the resin has not expired by checking the expiration date on the kit, and check to see if you have the right kit size for the socket you are pouring. A socket resin volume chart can be found on the fast funnel supplied with your kit. It is important to have ready and mix all of the resin and hardener needed for a socket at one time. In cold weather, be sure to have adequate booster packs on hand if required. Temperature plays an important role in mixing and pouring the socket resin. Read and understand the instructions, paying close attention to the resin gel times in relation to temperature, in order to prepare yourself to work within the gel time of the resin. If left outdoors in hot climates, the temperature of the unmixed kits of socket lock will increase, and the time it takes for the mixture to gel will be reduced. This results in giving the preparer less time to pour the resin into the socket before it gels. In hot climates, it is recommended to keep the unmixed resin kits in a cool place until ready to mix, so that the preparer has plenty of time to pour the resin into the socket and eliminate the chance of gelling while pouring. On colder days, additional hardener booster packets can be purchased, and when added to the resin, the additional hardener will speed up the gel and cure times. Please refer to the instructions provided with the kit for booster pack and cold temperature information. In the manufacturing process, granulated filler is added and mixed into the polyester resin. During long periods of storage, some of these granules may settle into a section of the pouch. First, feel the pouch to check for any granule clusters. If a granule cluster is detected, knead the pouch until the resin and granules are mixed. Tear open the resin pouch and squeeze its contents into the plastic container. Then, tear open the hardener packet and squeeze its contents into the container. Socket lock kits for larger, individually sized sockets have more than one resin pouch and corresponding hardener packet. Be sure to pour all of the resin into the mixing vessel before squeezing in the hardener packets. The same can be said if using multiple small kits to reach the volume of resin needed to pour a large socket. Thoroughly mixing the resin and hardener is very important to ensure the hardener reacts with the resin and the mixture cures properly. Mix for at least 60 seconds until the white streaks of hardener completely disappear. Be sure to scrape the bottom and sides of the container to ensure complete mixing. After mixing for at least 60 seconds and the visible white streaks of hardener have disappeared, you can prepare to pour the mixture. It is important to note that resin showing signs of gelling or has begun to gel should not be poured into the socket, as it is likely to trap air. It is best to pour all of the resin into the socket immediately after mixing while it is in its most fluid state. This will ensure penetration to the bottom of the socket and eliminate the possibility of trapping air. Once mixed, position the funnel so that it will empty the resin down the side wall of the socket. This will ensure that air escapes and resin reaches the bottom of the socket bowl. Pouring down the middle of the socket could trap air and create a weak area of the comb. Pour the resin slowly and move the funnel from side to side along the edge of the socket bowl. The resin will tend to spread horizontally if poured too quickly, and this can trap air in the socket bowl. Leaking is likely to occur and is a good sign that the resin has reached the bottom of the socket bowl. Work to plug the leak with more putty to prevent too much resin from leaking out. If too much resin leaks, a void could form in the base of the socket bowl. After the leaks have been plugged, check to see if more resin needs to be added. The resin should be even with the top of the socket bowl, which should be even with the top of the wires. Because the angles at which the broomed rope is positioned in the socket, some wires may be slightly above the surface of the resin, and some will be slightly below. Wires that are too high above the top of the socket bowl may interfere with the fittings attached to the socket. If the wires are too far below the surface of the resin, you may experience slight surface cracking after proof loading. Also, it is difficult to verify adequate wire position if the wires are too far below the surface of the resin, and may cause concern for some users. After some time has passed, the resin will change from a liquid to a gel. The gel time is determined by the temperature and begins once the resin and hardener are combined. Do not move the socket assembly until 15 minutes after the resin has gelled, so that you do not disturb the wires in the partially cured resin. Next, the resin will cure into a solid. The cure time is determined by the temperature and starts once the resin has gelled. Please refer to the socket lock instructions for cure times. When cured, the resin will shrink slightly, leaving a small gap between the socket wall and resin cone. This is normal and should not be a cause for alarm. If the socket is not equipped with an anti-pop-out or anti-twist feature, the resin cone may pop out during handling. Take caution when handling to prevent this from happening. After the approximate cure time listed in the instructions has elapsed, you can scratch the surface of the resin with a hard object to test for complete cure. A white scratch mark appears if cured properly. After the resin has cured, relubricate the wire rope to replace any lubricant that may have been removed during the cleaning process. It is recommended to proof load the assembly to twice the working load limit prior to putting the assembly into service, per ASME B30.9. Proof loading will seat the cone into the socket, removing the gap found between the socket wall and the resin cone, in addition to wedging the cone tightly into the socket and prevent it from popping out. When all of the procedures are properly followed, socket lock will provide 100% termination efficiency. A quick review of the key points to properly prepare the rope end termination with socket lock are: make sure the end of the rope is properly broomed all the way down to the seizing. Doing so will ensure the resin reaches the bottom of the cone and fills around each individual wire. Be sure to thoroughly clean all lubricant and dirt from the broomed wires. Be especially sure to have the wire rope and socket vertically aligned with each other. Not doing so will cause unbalanced loading on the wires that may result in failure. Mix resin and hardener completely. Make sure resin is poured into the socket before it begins to gel. Pour the resin down the side of the socket and not down the center to ensure air is not trapped. Thank you for watching this instructional video from CFit and Socket Lock. We would like to hear your feedback on our video series and ideas you may have for more socketing instructional videos. Socket Lock is available worldwide. Please be sure to visit socketlock.com for our contact information, list of distributors, MSDS sheets, more in-depth instructional videos, and information regarding all aspects of resin socketing. Thank you.